This is Dr. Nadeem Mahmood, and I welcome you all for the new lecture that is Developing Requirement in Object-Oriented Software Engineering. So, I hope that you have already listened the earlier two lectures regarding object-oriented software engineering. So, today's topic is how we can develop requirements in object-oriented software engineering. So, I hope that you have a little understanding of objects, classes, the basic concepts of object-oriented software engineering, which we have discussed in the previous lecture, and moving forward to requirement analysis. So the first thing which we have to think about wherever we are going for the requirement analysis, requirement elicitation, requirement collection, the first very step is domain analysis, which is very important. The process by which a software engineer learns about the domain to better understanding the problem, because whenever we are developing requirements for an application or a software, it is very important for us to find out the information about domain, what actually the domain is, and what to understand the basic concept regarding domain. For example, if we want to develop an application in a banking domain, so it is very important for us to go for the domain analysis. If we are building an application for embedded software, for example a vehicle, there we need to understand what the domain is. So every domain has its own knowledge, and which we have to find out while we are developing such softwares. So domain is what? Is the general field of business or technology in which the client will use the software. Whether that software can be used in a university based system where we want to facilitate our students to find out various courses and to register themselves, whether that application is being used in banks, for example for loan applications. That software might be used in the car industry, where we want to determine some of the behavior of the engine, and that can be integrated into any vehicles which are on the road. So domain knowledge is essential while we are gathering requirements. So domain expert is a person who has a deep knowledge of this domain. So domain expert is an individual who has the knowledge of the system. Does not mean that that individual has the highest degree of qualification in a particular domain. It means that domain expert is an individual who has the knowledge. For example, if you are to develop an application which is used for travel, air travel, or for travel agencies, so there the domain expert might be an individual who is working in this particular travel domain and has the knowledge, required knowledge, which may be essential for you. So domain experts are very important. Let's suppose if we are building an application for health individuals or healthcare environment, so there we need to know, obviously we need to interact with domain experts to find out the exact knowledge about the domain. Therefore it may be reflected into our system. So benefits of performing domain analysis: it will really help us for faster development and obviously lead to a better system. And we must have the anticipation of extensions, because we should know that while we are developing these requirements, the extensions might come. So we must have that understanding that what might be added in the future. So domain analysis document, which is a standard document, whenever we are performing such domain analysis, we need to have that information on one page or on one document, which includes the introduction about the domain, glossary, all those terms which are relevant within that domain, which is very important. For example, if you are building an application for healthcare system, so there we have some special terminology, so we have to we have to represent that glossary in that document, so it gives you a better understanding of the domain. General knowledge about the domain, it is very, very important. Obviously, when we are building such systems or an application, we need to have a good understanding of the domain, customers and users, which is very, very important, because if we are tackling any domain, we need to know that who are the clients, who are the users of the system. So because we are developing that system in the perspective of those users, so therefore that has to be covered in the domain analysis document. The environment, obviously the environment has a bigger picture where that application will work. So obviously that application or a software or a system will work in a certain environment where it has a certain input, where it has a certain output, and they are dealing with certain other entities as well. So all those relevant entities, all those inputs, outputs to the system basically creates the environment. Tasks and procedures currently performed. So while we are conducting domain analysis, we must understand what are the tasks and procedures which are right now being performed in that particular domain, because the reason is that those tasks and procedure has to be either re-engineered or reproduced, or obviously that can be covered in our application. We should know about the competing software, which is very, very important, because while we are developing an application and while we are collecting requirements, it is very important for us to know that what are the competing softwares. For example, if you are building an application for a university based system, so there are so many other systems which are there, which have been implemented. So you should know what are the competing software, how they are tackling these requirements within their systems. So this will really help you while you are conducting your domain analysis and requirement analysis. And also at the end, it is also important to know the similarities to other domains as well, because while we are developing such applications, there are so many things which are in common with the other domains. So that is basically, you can say, the ingredients of domain analysis document. The starting point for a software projects, you can see this matrix, and it is easier for us to understand in the beginning. So while we are developing softwares, if you see on the left hand side, the horizontal side, you can see either you can go for new development, which is normally called greenfield projects. Totally a new development, it means you are starting from scratch, or either you can go for evolution of existing system, because in most of cases you identify the problem, and instead of going for a new software or an application, you go for evolution or a change within the existing system, so that it can work now in that situation. So if you see on the vertical side, you have requirement must be determined, or the other option is the clients have produced requirements. Either you want to collect the requirements from the start, from the beginning. Now, and the second option is that the requirements have already been produced. So keeping that matrix in mind, so obviously 2 by 2, it means there are 4 possibilities, A, B, C and D, which you can see here. A represents that you go for the new development, and the requirement must be determined. Number 2, you are going for the evolution of the system, existing system, but you have to determine the requirement. So this is option C. Similarly, we have an option B with new developments, and clients have produced requirements, and new developments and evolution of existing system with clients have produced requirements. So there are 4 options. So one of the 4 options is being used. How to define the problem and scope. This is one thing which is very, very important while we are developing any software or an application or a system. We should know what is the problem and the scope of the problem, because that is one thing which is sometimes we missed out. Either we go for a scope which is unlimited, or sometimes we are defining a problem in a vague manner, or ambiguous manner. So problem definition has to be very clear. The problem statement should be clear, and obviously the scope should be well defined, where we exactly know that this is what we want to do in with this project and an application. A problem can be expressed as difficulty the user or customer are facing. This is one way of expressing the problem, because let's suppose I have an application running already and there are lots of complaints from users. Might be those complaints are regarding in issues and inputs, might be that is related to updates, might be that is related to retrieval, uh, so many things which might be related with the user or customer, and obviously that you can easily know if you have a feedback system, or as an opportunity that results in some benefits such as improved productivity or scale or sales. For example, sometimes you do not have so many complaints from user or customers in terms of usage of the application, but you might observe that your system might need change, because you need to optimize your application or a software for better performance. For example, here you can see that for improved productivity, again it's an optimization, or you want to have more sales. So sometimes we need to add new things into your system. The solution to the problem normally will entail developing software. Narrow the scope by defining a more precise problem. What is the solution? The solution is you can might go for a new system. You have two options, as we have discussed in the earlier slide, or you can go for the new system to resolve that issue, resolve that problem. List all the things you might imagine in the system doing what thing. One way of representing a scope is try to find out all those things which you believe that your system can do, and then exclude some of these things if you believe it is too broad, and determine the high level goals if too narrow. So this is the way of approaching to your scope. Write down all those functionalities which you might think your system might offer, and later on decide which things you want to cover in the first go, and which you believe need to be excluded. So you might have you obviously you discuss with the customer, the users, and then you find out what is relevant and what is not relevant. So determining a scope is not the decision which lies on the developing side, but it is very important to engage those users who are actually bringing out that problem, and for whom we are developing that application or a software, to engage those users to find out what is their actual requirements and which requirement need to be covered in our solution. So that is again a tedious process, and that is also called an abstraction. So you see one small example here. Let's assume that you are developing a university registration system. So in the first go, what you can do is you can select many options or issues which might be included in your scope. Might be you are looking for browsing courses, providing facilities to the students to browse courses. You want to improve some registering process, a fee payment process, room allocation, exam scheduling, class scheduling, for example, selecting a final project supervisor, so many things which might come. Just for an example, you can see few here. And what you did in the next step is that you narrowed the scope. So while you narrowed the scope, you have selected, for example, browsing courses and registration. And scope of another system might be the room allocation and exam scheduling, which is a different thing. And obviously you can relate later on to a fee payment to it. So find out the all possibilities and then try to determine what is your scope. So in a university registration system, the users might want to implement many functionalities, but they might prioritize them in terms of their requirement. So you can also narrow down your scope as per the user requirement. So if you talk about types of requirements, so there are generally 4 types of requirements. One is called, which is very important, you all know about it, that is functional requirements, which is the topmost requirements, which is the most important part while we are developing requirements, and which describes what the system should do. It means that is all related to the functional part. In the previous example, we talk about registration, we talk about payment, we talk about other functions as well. For example, course registration. All these things are functional. For example, you talk about a bank. So in a bank, you want to go and open an account. So opening of an account is a functional requirement. For example, from your account, you want to make any transaction. That again, that is a functional requirement. You want to close your account, it's a functional requirement. So all these are functional requirements. Later on, we can see in detail what functional requirements are. The second thing which is very important while you are developing application are the requirements which are normally called non-functional requirements. And these non-functional requirements include quality requirements, the constraints on the design to meet specified level of quality. So we are not only interested in developing software or a program or an application, rather we are more interested in developing those applications, keeping in mind all those quality standards which are known to us and obviously that are part and parcel of the system. So the quality requirements might include for example, the reliability factor, for example, the availability factor, for example, we look for optimization, or we look for other things, for example, user friendliness, ease of use. For example, there are so many other parameters which are related to quality requirements, which we will discuss in the next slide. The third thing which is important while we are determining those requirements is a platform requirements, constraints on the environment and technology of the system. So we are implementing that application on a software, obviously on a certain architecture, on a certain framework. What type of application is this? So what are the constraints which are related to it? For example, if we are developing a distributed application, database application, which is need to be implemented, so there are certain constraints, how that network work, how the different sites are being organized, how, for example, the network infrastructure is there, what type of topologies are there. So all of these are platform requirements which are important. Or for example, you want to have a mobile based application, and which is let's suppose for the Android users. So you are specific, therefore there are certain platform requirements. Then the process requirement as well, constraint on the project plan and development methods. So while you are developing software, the process is also involved, because whenever we talk about developing a software, you remember that the concept of process and a project. So project is something which is deliverable, just this is something which is an output, but to have that output we have to go with a certain process, and those process requirements should be met. So those include project plan, how you can move forward, what is your timeline, how those tasks being identified, what are the milestones, what are the process models which you have invoked during development process, whether you go for a waterfall model, whether you go for a rapid application development, whether you go for the spiral model, whether you go for a rational unified process model, or for example you are going for agile methodology. So this all comes under process requirements. So functional requirements include all inputs to the system, all outputs to the system, what data the system should store and the system might use. So what is the strategy about the data, which data you want to keep within the system, all those computations and processes which are being applied, all are included in functional requirements. So in any case, for example, if you are developing an application for an hospital, you are always interested to know that how those patient will be registered, what type of information is required for registration of a patient, how you can record all those treatments, how the lab test reports will be generated, how the for example various payment invoices will be generated, how the payment will be collected from the patient. So all these things are under functional requirements. For example, take a good example of ATM. You are using ATM machines, so the functional requirements are obviously whenever we are using our ATM cards, so it starts from validating yourself, and then later on you can perform certain tasks. For example, you might go for withdrawal of a cash, you might want to transfer amount from one account to another account, you want to pay bills, and do so many other tasks. So all these tasks are basically the functional requirements. So in any software or in any application which you want to develop, the first most important thing is to determine all those functional requirements, because your application or a software must exhibit all those functional requirements whenever you develop your product or a project. So this is about functional requirements. Quality requirements means you might be talking about a response time. So everyone want to have a good response time, good throughput as well, resource usage that is related to optimization. For example, you are achieving a task, but in how much time you achieve a task. For example, in case of database system, you want to optimize the query. So optimization of queries is also related to resource usage, or you are utilizing a network resources. So how best you can utilize the network resources, or even you are utilizing the processors, so how you utilize those processors. So all comes under resource usage. Reliability is very important aspect whenever we are developing such application. Reliability refers to, you can say, how the systems is resilient to failures. Means that whenever your application or a system or a software is running, whether that has that capacity or resilience against failures. If the failures are too often, it means your system is not reliable. Availability, recovery from failure as well is important quality requirement. So in case if there is any failure, systems might fail. Best of the best systems of the world, which have been developed by the best of the best companies, even from the Microsoft, from IBM, or the products which are other products which are, for example, mobile phones, vehicles, even aeroplanes being developed, but there are certain failures which might come over a period of time. The important thing is how the system will recover from failures. The other issues which are related to maintainability, because the system has to be maintained, and of course the concept of reusability. So these are all the quality requirements which need to understand. Use cases, what use cases is a typical sequence of actions that a user performs in order to complete a given task. So what use case is? Use case is basically a sequence of actions, means a scenario or a situation, but that situation is being designed or is represented in terms of the user's perspective, how user performs it, so how user interact with the system. So that has to be captured, and that is considered as a use case. So use case itself basically describes one of the functionality, one of the functional requirements. Normally we do not design use cases for non-functional requirement, that is always designed for functional requirements. The objective of the use case analysis is to model the system from the point of view of the user interact with the system when trying to achieve their objectives. For example, a user might interact with an ATM machine to perform a certain task. So whenever we describe those use cases, we make those interactions or steps to see that how that functionality is being performed. For example, the user want to withdraw a cash from an ATM machine. So it is a functionality, it is a use case. So it involves certain interactions. So the users which are involved in the interaction with the use cases are also called actors. So actors is something which acts and perform interaction with the use cases. it is one of the key activities in requirement analysis to determine those use cases. So it means why we are determining those use cases, why we are finding out those use cases, because we want to develop a use case model, which is one of the important model or a basic model, or one of the, you can say, a model which is being used later on in all other models as well. A use case model consists of a set of use cases, number one, because there are not one functionality within the system, so obviously there are few functional requirements. So all those functional requirements combine together to form a set of use cases. So obviously when we are talking about a model, it consists of set of use cases, an optional description or diagram including how they are related, and later we can see that those use cases might have a certain relationship, and the actors are actually the entities which are actually involved in the interaction among those use cases. Here you can see the example and you can have a better understanding. So remember that all those use cases in a use case model is represented in an oval shape, and normally you give it a name, any name which you think that gives a better understanding in your own problem domain. For example, this problem is related to university registration system, so therefore we have certain use cases. Does not mean that we have only these use cases. This is just for an example purpose. So here you can see the 5 use cases are represented, and use cases are represented in an oval shape and a name, and you can see the one of the use cases add course offering, and another case is use cases add course, register in a course, enter grade for course, and find information about course. So you can see these are 5 use cases which are being represented, and similarly you can see that there are few actors which are involved, and there is a connection of those actors with those use cases. It only represents that these actors are part of the interaction within that use case. For example, register in a course. So you can see this, that is the job of the student to register themselves in a course. So therefore a line is associated with a student which actually depicts that that student is part of the interaction within that use case. How it is the part of the interaction, what actually the interaction is not represented in the use case model. It is represented in the use case description, which is normally represented in terms of a use case template. The diagram is simple where we have this understanding. What to cover in the use case? So these are some of the things which try to cover in a use case template description, which include the name of the use case, as you have seen, for example, the registration of a course, actors which are being involved, so there might be a single actor or more than one actors, goals, explain what the actor or actors are trying to achieve, what is the target, what is the task, preconditions, state of the system before the use case. So if you want to run any functionality, you need to know what are the preconditions. For example, if you say that actor should register for a course, for the registration of the course, that student need to be registered him or herself first. So if he or she is a registered user, only then they can go for the registration of the course. So the preconditions are met. Summary is means short informal description about the use case. Related use cases, for example, talk about registration, so whether the student is registered or not may be related, whether the student have completed the prerequisite for those courses, so that is something which is also a part of it. The steps means you can go for 1, 2, 3, 4, 5, 6 steps, whatever way you can describe it in maybe in a sequential manner, that how that use case is being performed. Post condition means the state of the system in the following completion. For example, this student registered for a course. So as soon as the student registered for this course, the state is being changed. Now that course is being allocated to that particular student. Okay, now the system has changed the state. Now later on, the student might change or replace the courses which they have been registered. or they cancel the registration, but that is the post condition. Alternative scenario means all other options which are quite might possible while executing these scenarios or situations. So we can also capture all those alternative scenarios. Therefore, it is important whenever we are developing those use case templates, we are not only interested in successful scenario or a completion of a use case, we also consider the unsuccessful scenarios, the situations where might be that use case will not work. For example, for an ATM, a user go for a cash withdrawal, but that cash withdrawal might fail for a certain reasons. Those reasons might be there is no validation of the user, there might be no validation of the user, might be the system is not working, not responding, might be there is no cash in the cash dispenser within that ATM, or any other block which is there on the account, so therefore that transaction cannot be done. So it means there are certain alternatives as well, so we need to capture those alternatives as well. This is a short description of use case template, which is regarding a library system where you can register a book loan, and here you can see that there are certain dependencies which are there, description, preconditions. For example, the library user has been identified by means of his or her identity card, blah blah blah. So ordinary sequence is also there, stepwise. What is the first step, what is the second step, so on and so forth. Post condition, exceptions. For example, for in any case, if there is any exception, that can also be listed in a use case template. So how many use cases you might have in your problem domain, you have to have those templates available for all those use cases. There is also a relationship among use cases, and the two important relationships are called extensions and inclusions. Extensions are represented as extend, and inclusions are represented as include, or sometimes we also call it uses. So first we talk about extensions. Extension refers to the relationship of use cases where you want to exhibit or you want to represent that after execution of this use case, you can also execute the following use cases. So it means that reaching out to a post condition, from there you can execute other use cases as well. Used to make optional interactions explicit or to handle exceptional cases. So in both conditions, those extensions might work. The second aspect is regarding inclusion or include, or sometimes we also call it uses. It means that in performing one use case, you need to perform the other use case. So it is important for you, while you are going for this particular use case, you have to perform another use case. If you have this dependency among the use cases, that comes under inclusion. Even very difficult use cases can share sequence of actions, enable you to avoid repeating details in multiple use cases. Example, basic use case. A simple example you can see here, the online shopping system. Here you can see the view items include make purchase. So if you go for the view items, it is important for you to look for a purchase. So make purchase is a part of the view item. So if you perform the view items, you can also go for and perform make purchase. Similarly, complete checkout. So this is also represented here. If you want to make a purchase, you need to complete checkout. As we go for online purchases, where you have observed, you just select few items, then you put it in the cart, and they always ask you to complete that transaction. It means that confirm it, reconfirm it, and then that your purchase is confirmed. If you do not do this task, obviously that purchase is not confirmed. And you can see that there are various actors which are being involved. So actor does not mean only the individuals. Actors might be a sub-process, actors might be a system itself, actor might be an organization. Here you can see a PayPal. So you all know about PayPal, which is there for all that money transactions, online money transactions. So here you can see the PayPal is also there as an actor. Credit card payment service is there, identity provider, as well as service authentication. So that are there only you can see the 4 use cases: view items, make purchase, complete checkout, and login. So this is online shopping system. So there is one other example for you To see further details or more elaborated diagram for use cases, that is for the library management system, and there you can see many use cases. For example, authenticate, reserve a book. How you reserve a book, it includes certain steps. So how user go for reservation of a book, request for a book, renew a book, pay fine, uh, for example, update catalog, which is the task of the librarian, not the user. So therefore, you can see the librarian interaction is there. A librarian is responsible to add a book, delete a book, edit a book. These are sub functionalities which are included into the update catalog. Similarly, there is a user which is where there is an actor which is called database, which is responsible to send overdue notification. So automatically it evaluates, and whenever that date comes, that notification is being generated, so on and so forth. And here you can also see other use cases and their relationship. So with this, I conclude my lecture, and hopefully that you have a good understanding of requirement analysis. And for your feedback, I am there. Also go and refer the book chapters as well, and please give me your feedback, which is very important for having new lectures as well. Thank you so much. Looking forward to have another lecture soon.